Awesome. So my clock here says 3:15, so we're going to go ahead and get started. Welcome to Diagnosing. Oh, sorry, you can't see that yet. So there we go. Welcome to Diagnosing Issues in Production using Visual Studio 2013. My name's Andrew Hall. I'm a program manager on the diagnostics team in Visual Studio. We own debugging, profiling, and the IntelliTrace tools, but we work with most of the other teams inside Microsoft that do diagnostic tools as well. I'm guessing that most of you, probably because you're in this room, don't ever actually write bugs in your own code, but that's okay. The purpose of this talk, because production applications are hard, we're going to also look at tools that will help you blame the other guy whose fault it really is. Sometimes it's just the hardware's fault, right? Actually, there's a series of mail that's going across that I'm not in the office right now, thankfully, but a network switch went bad, so nobody actually back on the debugger team in Visual Studio has internet access right now if they're hardwired in. So the problem with production diagnostics is there's just so many things that can go wrong in those environments, and a lot of times it's not even that you did something specifically wrong, it's that you forgot to account for the fact that something else could go bad, right? The network could go down, the database could go down, right? It's always the other guy's fault. But so for the purposes of this talk, first thing I'm going to hammer on is symbols and source code. Symbols, symbols, symbols. If you learn nothing else from this talk, stay for the first 5 minutes. We're going to talk about symbol files. How many people here know what symbol files are? Okay, most people are raising their hands. That's good. And then the next thing, we're going to talk about remote debugging. How many people here have ever remote debugged with Visual Studio before? Okay, fair number of people. Awesome. We're going to talk about the profiler. Profiler includes a standalone profiler that you have by virtue of having Visual Studio, if you have at least Visual Studio Professional. And a lot of people don't know that. I talk to a lot of customers that say, oh yeah, we bought this other suite of tools because we needed to profile something. And I said, well, did you use the one that comes with Visual Studio? And they said, no, Visual Studio doesn't have one. So we're going to talk about that. We're going to talk about IntelliTrace. How many people here have seen a talk on IntelliTrace before or know what IntelliTrace is? Okay, about half the room. We're going to talk about our new managed memory analysis capabilities that we have in Visual Studio. That's new to Visual Studio 2013, so when you have a memory problem running in production, we have tools to help you solve that. And then last but not least, we're going to talk about dump debugging, so kind of the old trusty way of diagnosing issues in production, but Visual Studio has some pretty good support baked in for that as well. If you have any questions throughout the talk, feel free. There's microphones here. The room's not that big, so if you shout it out, I'll try to repeat the talk. But please feel free to ask questions throughout the talk. I want to make sure that you get the most out of this. If you're experts on all of this and you want to leave, I'm not offended. I want to make sure that you get the most out of your time as well. So first thing we're going to talk about is symbol files. Symbol files are the mapping between the source code and the compiled binary. It's basically the record of how the compiler translated your source code into the code that actually executes on the machine. Without symbols, if you don't save your symbols, you will never get back to your source code. It's as simple as that. And unfortunately, we deal with a lot of people that are sort of new to migrating stuff to the cloud, new to sort of putting stuff up in production, and you walk in and they said, okay, well, we have this problem, and we have this application that's been running up in production, and it was built a year ago, and nobody's touched it, and now it's having a problem, so how do we debug it? You say, okay, where are your symbol files? They say, what are those? You say, the PDB files. They said, I think we deleted those. So that's not a good thing. In the debugger, when you're debugging, it's used for setting breakpoints, again, mapping between source, and for showing call stacks. In some cases, if you have a managed process and you're attached to the live process, we don't need the call stacks in that case. If it's native, we need the symbols, native being C++, or if you get a dump back that doesn't have the memory in it, we're going to need access to the symbol files to be able to show you that call stack as well. And symbols must be from the exact same build as the binaries. This is another one that bites people a lot. You can't go pull your source code back out of production or out of source control, say this is the version that those binaries were built from, recompile it, and have it work. Every time you compile stuff new, a random GUID is assigned to the PDB. All the diagnostic tools look at the GUID in the binary header. They look at the GUID in the symbol file, and they say, do these match? If they don't, all bets are off. It's not going to load it. It's not going to let you use it. So, and I said, archive the source and the binaries together. We will let you mismatch the source files, and I can show that here in a little bit. But if your sources are mismatched, it's going to go to whatever line of code that was when your application was compiled. So if you have a crash that occurs on line 3 in the original source, and that's now line 10 in your sort of source files that you're telling the debugger to use, it's going to take you to line 3 and say the crash was here. And so it might say you have a crash on some random using statement because you're, and obviously that's not going to be correct. So archive symbols in source for anything that you put into production, and your life is going to be much, much more pleasant. So the first tool that we're going to talk about in the arsenal of tools to go debug issues in production environments, I'm defining production environments kind of loosely here, basically meaning not running on your machine, is remote debugging. It allows you to attach a debugger via a networking connection, which is actually pretty cool. I thought when I first joined the team that was a really slick thing. And you have effectively the same debugging experience that you would have locally. You can set breakpoints, you can step, you can inspect objects, you can use almost all the tool windows. The only things that aren't going to work are things like edit and continue, because we don't have at the moment we don't have the ability to sort of go patch that process on the remote machine. But other than that, it's basic debugging. It's ideal for test and staging environments. Those of you know how debugger works. If you're attached to a process and you hit a breakpoint and you're stopping and looking at something, that process is not actually running anymore, which means that if you're sort of in an environment that other customers are expecting to get to, they're going to be seeing server not responsive errors because that process is going to be not responding while debugger's attached. There's times where that may be what you have to do because the service is in a really bad state and you don't sort of have the ability to set up a test and staging environment, but be aware of the fact that nobody else is getting access to that. You're basically the exclusive user of that when you're stopped under the debugger. Nice thing about the remote debugger, it's a relatively small downloadable installer. You can get it from the web. Just do a search for Visual Studio your version remote tools. You can pull it down. You don't have to specifically go copy anything over. You can ask your operations team if they have that. If you have one of those, to go download and install that for you. And the great new thing is it's also supported now in Windows Azure. So I don't know if anybody's seen a talk or has used that yet, but you have the ability to remote debug to things running in Azure. So it's not just your on-premise things as well. So let's go ahead and take a brief look at remote debugging and how that's going to work out for us. So I have an application running in production. Production here being just a separate machine that I'm remoted into. I brought my own router to try to make sure that we didn't have any connectivity issues per my earlier comments, but if something goes bad, forgive me in advance. So I've tried to get to this website, and it's telling me that it failed to load application. So there's some error that's occurring, and I want to figure out how to remote debug that. So I've already installed the remote debugger over on this machine. So if I just type remote, you can see that it's there. And because I'm going to be debugging to IIS itself, I have launched the remote debugger as an administrator. The debugger has sort of the same restrictions as when it's running on your local machine. It can only attach to a process in the context of the user that it started under that credentials. So in most cases, in a production environment where you're going to be running IIS under a system account, if you're launching the remote debugger under your own credentials, you're going to have to launch it as an administrator, because for security reasons, the operating system is going to say, no, a debugger that's running with user permissions can't talk to a process that's running in a different user's process. That's a good thing. So we're going to just go ahead to Visual Studio. And a couple things I'm going to talk about here while we're remote debugging. There's a couple gotchas that are important to be aware of. So I'm going to say debug attached to process. And we're going to go ahead and find a remote machine. If it's on the same subnet, it should find it automatically in this find dialog. If it's not on your same subnet, that doesn't mean you can't connect to it. You'll just have to manually type the IP address to the machine. We use the same technology to find the remote debugger that Windows Printer Discovery uses. You may or may not have had good luck with it. I haven't had particularly good luck with it in sort of distributed systems because routers a lot of times don't let those packets flow through that we use to find that. But just because you can't find it doesn't mean you can't manually type the address to it and get to it. And you can see actually after I selected it in the browser dialog, it in fact replaced it with the IP address anyway. It didn't keep using the machine resolution. So decided that it wants to, I don't know what I did, but let's give it a second to come back. And so over on the remote machine, you can see every time that I've connected, there's actually going to be a log of things that it connects to. If you're in an environment where you have to ask an IT person to let you use the remote debugger, you can actually give other users permissions on the remote debugger, and then it'll work with those credentials. So just using Windows Authentication and Active Directory, you have the ability to come into the remote debugger and configure. So operations can start it. They can give members of your team permissions to actually attach to that instance of the remote debugger. So I somehow messed up the IP address is what the problem was. Come back. I selected an old IP address. That's why we had a problem. So I'm going to go down here. I'm going to select W3WP, and I'm going to click Attach. It's going to give me a warning, and I'm going to say, yes, I want to attach. So now I'm debugging like I normally would. And this is the first gotcha that I want to talk about, because I think this is a very important gotcha to be aware of with any remote debugging, and it came up in Azure recently as well. So I'm going to open the modules window, and the name of my DLL for my thing is Web App Entity. So I'm just going to type Web App. For those of you who haven't seen Visual Studio 2013, we've added search in the modules window, which is a great thing if you've ever spent any time in the modules window. Look at how long this is. It would have been a pain to go through and find Web App Entity. So I'm going to type Web App, search. And the first thing to be aware of in production diagnostics is you're going to see this symbol status says skip symbol loading for my DLL. How many of you went to the debugging tips and tricks talk? Okay, about half the room. So in Visual Studio, we have this thing that we think most of the time is a really good thing in your F5 scenarios called just my code. And just my code, one of the criteria it uses for managed is we say if a binary is built optimized, it's probably not your code, meaning most of the time you don't want to debug into it, so we're not going to load symbols for it. Without symbols, we can't hit source, we can't have any information like that. So in this case, I'm going to have to go to Options and Settings under my debug, and I want to disable just my code. So we'll go ahead and disable that. And now it's going to go ahead and I'm going to tell it to load symbols. And it's going to tell me that it can't find my symbols. Fortunately, I wanted to make sure that everybody saw this. I had saved my symbols. So let's go to my archive. I think this is my build, binaries release. And once I get to the folder that my binaries are saved in, it's going to automatically, I don't have to pick the symbol file specifically. If it can find the file in that folder, it's going to automatically grab it. And the other great thing that it's going to do for me is it's going to automatically add that path to my symbol files path under Tools, Options, Symbols. So now, any future diagnostic sessions I do, whenever I debug, whenever I use the profiling tools, any of the binaries that are in that path, it's automatically there. It's just going to look there. The other important thing that I want to talk about was source. And we have properties on solution. So every time you do anything in Visual Studio, you get the pseudo solution here. So if I don't have the actual project loaded that my process was built from, I can go to this debug source files, and I can actually add paths to where my source files are. So they're just going to be found for me when I do something. So I'm going to go ahead and wait on that now. We can browse for things later. The debugger will prompt me as I do things. The last big got you with the just my code thing is, so let's go ahead and take a look. And I'm going to go ahead and I've pre-opened this. And I'm going to click this About page to force an error to occur really quick. We'll go debug what the failed problem is earlier. But in this About, I'm going to see an error occurred while processing your request. Notice the debugger didn't break. The reason the debugger didn't break is when I'm doing any type of web framework, we have this concept of user unhandled exception when you have just my code on. So anything that's in your code, if you don't handle an exception, once it starts to leave your code, the debugger will stop you and it'll say, hey, this exception was user unhandled, meaning somebody may handle it later, but we noticed that you didn't handle it, so we're going to let you know. As soon as I turned just my code off in this case, the other big thing that got me was there's no concept of user unhandled. So the ASP.NET runtime, because this is MVC applications, can actually catch that exception for me, right? My W3WP process doesn't crash every time I have an error that occurs in my code. So now the concept of just attach to the process, turn off just my code to make sure that everything works right because it's optimized, and wait for the debugger to tell me when something went wrong, unfortunately goes away. But if I look in the output window, I can see this message that says a first chance exception occurred, and it's going to tell me where it occurred. So I'm going to go into debug, option or exceptions, which is right there. And I'm going to ask it to now break whenever exceptions are thrown. So this is going to make sure that I get alerted whenever that exception occurs on the machine as opposed to having to wait till that. So I'm going to go ahead and click About now. And it's asking me where my source was. So I mentioned that we could browse for it later. So I'm going to go here. I'm going to go to my sources folder. And this is the controller. So I'm going to say controllers. And just like it did for symbols, it's going to break. And it's going to tell me that a null reference exception occurred. So this is a stupid little bug I stuck in to kind of show you the experiences without waiting for why the other problem was occurring. So now that we have our process set up correctly and we understand what's going wrong, we made sure that, yep, lots of first chance exceptions occurring now. In our process, let's go ahead and choose not to break when this exception type occurs anymore. And say F5. And so now let's go ahead and turn on first chance exceptions again. Now that we're sort of out of that path, that was bad. And let's go ahead back and wait for our other error that occurred on just our home page. So while we're waiting for that to break and tell us what the problem is, anybody have any questions? Oh, perfect. So I can see that I have a SQL exception occurring. And in this particular case, I moved the application from my machine into my production environment. And so it's telling me that I had a bug. And so I'm going to drill into my database object. And I'm going to see that I'm sure nobody has ever made this mistake if they've moved stuff into production before. But I actually had forgotten to update my connection string on my production machine. So it's still trying to connect to localhost, and it's trying to use integrated security with my Windows credentials, which isn't going to work very well in the IIS world where it's running under a system account. So let's go over to our production machine. Let's just find the right place in the web.config file, which somehow just happened to be open in Notepad already. Amazing how that happens on demos, right? So let's save it. Let's come back to Visual Studio, or to and eventually, 1, 2, 3. There we go, and it succeeds. So I actually use remote debugging all the time when I move ASP.NET applications from my machine into production environments. I'm sure everyone that's ever done it before understands how hard it is to remember to set all your right config knobs. Sometimes, a lot of times you're using IIS Express on your local machine. It's x86. You put it in production. Some of the dependencies were x86 only. All of a sudden, it's failing because it's not loading modules. And so remote debugging is a great tool to do that. Oh, the last thing I wanted to show, just because I promised I would mention it, is in Server Explorer. I promised that you mentioned that we have Azure. So Windows Azure, I can use it for my cloud services, my websites. It's going to go ahead and load my websites, and then I can actually just right-click on a website, and I can say Attach Debugger, and that's going to go do the right thing up in Windows Azure, and I can hit breakpoints just like I was remote debugging to my other machine. I can remote debug to my Azure website running up in the cloud. So we think that's a capability that's really important as people start to move to Azure. So. Yeah, so the question was, can you force it to break when you're not doing an exception? Absolutely. So one thing that certainly works, just like you would expect, and I mentioned this before, but is breakpoints work. So if I say attach now, and I attach, I can set a breakpoint, just like I was live debugging in my F5 cycle. And then we have this asynchronous break button here, which no matter where you are in the code, you'll just force it to break. So for example, if you have a hang and something's just taking a long time and it hasn't broke yet, there hasn't been an exception occurred yet, you can click that and it'll stop you on whatever instruction's currently executing. So you might see that, oh, it's breaking because it's waiting for some SQL call that's hanging or some other service for call that I have. Did that answer your question? Yes? Okay. Okay, so the question was, when you give someone permission to use the debugger on that machine, they can't run it in administrator mode. They get the credentials of what it's running under. So if you launch as an administrator, and you give them permissions to connect to that remote debugger, because it's running as an administrator, they can attach to any process on that machine at that point. Correct. Yeah, so the clarification was, he said, when you launch it, you're giving permissions for someone else. Right, so we use Windows authentication by default. And so there's actually an option on the attach to process dialog where you can choose no auth mode and on the remote debugger. But by default, it's going to use their Windows credentials when they try to connect. So we also support remote debugging to devices. So if you have like a Windows Surface running on ARM, you can launch remote debugger there. And it'll actually prompt you on the Visual Studio machine for the credentials on that machine, because that machine's not going to be a domain-joined machine that your Windows account's going to propagate across. So in that case, if you don't explicitly grant someone permissions ahead of time, they'll get a challenge. And if they provide a username and password and that authenticates correctly on that machine, then that will work as well. So yes, another question. Okay, so the question was about why I turned off just my code. So in the case of so first of all, the question, and then he said if I have a project. So if you have a project open, regardless of whether you have debug or release set, when you press F5, we're going to load symbols for everything that's in that project. But when you attach to a process, we then sort of fall back to our heuristic of, can we find symbols and is it optimized? And if it's optimized, like I was attaching to my production machine that was deployed as a release configuration, it had been loaded, all the modules were optimized by the jitter and everything, the debugger basically was saying, okay, this isn't your code. So I could have done two things at that point. I could have right-clicked on it, and I could have just forced symbols to load, which would have only applied to that session. And the next time I attached, it also wouldn't have loaded those. Or what I did is I went in and I turned off just my code, and then that basically says in the future, whenever I attach, just load symbols for anything that you can find. The main reason that I turned it off as opposed to just right-clicking and forcing it to load for that one session is I wanted you to see the behavioral difference when you had that unhandled exception, the concept of user unhandled versus a first chance exception. So had I right-clicked on it, it would have actually just broken when it left my code because I forced symbols to load. The debugger would have said, okay, you now want us to treat this as your code. Did that answer make sense? That was very wordy, sorry. All right. Yes, another question. Do you restart the web application with with web config? So the question was, do you restart the web application with debug? True. No, we don't have to restart the application. We can attach to the process as is. So, any other questions? All right. So we're going to, oh, sorry, one more. So the question was, where are your symbol files? For the purposes of this demo, I have them on a local store on this laptop. I don't trust putting things out on the web at conferences. But internally inside Microsoft, for example, when we debug Visual Studio ourselves, we have a build server that's running, somewhere else that's not in our building, and we load all the symbols via an HTTP symbol server. Correct. So the question was, the symbols don't have to be physically present, and that's correct. We resolve the symbols on the Visual Studio side. So if Visual Studio, it's gonna, can access it on a UNC share. So if you have a whack some path, if you have an HTTP symbol server, if you just have it in some file share. So if you have a symbol cache set up on your local machine and you have the symbols there, we can load them from any of those. And in the symbol settings that I showed, we'll go search all of those paths, including the cache. Did that answer? Okay. So Profiler is one that's a little bit less well known to people. It sometimes is a little bit scary or something that we don't think about as much, because a lot of times we're very focused on, is the application working? Are my customers happy with it, meaning they can get to it? Performance is actually another big one that if you look at one of the top complaints for applications that people have, frequently, okay, fine, it works, but it's unusably slow. Everybody here, as I'm sure seen, use some product where it ghosts over for a little bit, goes white. You're just requesting a website. It's taking a long time. And you're going, what's this taking so long? Why? So right after correctness, performance is a very important thing. And the interesting thing about performance is a lot of times if you make sure to be on top of it as you're developing your application, you can do a pretty good job of nipping big issues in the bud so they don't escape and then result in complaints coming in from your customers. So we have 4 tools available from the command line in the profiler that comes with Visual Studio. We have CPU sampling. This is the one we're going to briefly take a look at here in a minute. Usually we recommend people start with CPU sampling. It's very low overhead. Typically about 2 to 3% is how much it will slow down your process. So for most users, they're not even going to notice that. If you have a request that takes under 5 seconds to complete, increasing that by 2 or 3% really isn't going to affect your customers. So this is sort of the one that if you need to go run it on a production environment, you can probably get away with doing that without impacting your customer too much. We have an instrumentation profiler. This one's a little bit harder to get set up. It'll show you every call and how long it takes, how many times it was called. Instrumentation is going to be much more impactful on the performance of your application, and it can generate a lot of data very quickly. We have a resource contention profiler, so if you're interested in where do you have contentions in the system, a lot of times you see problems like lock convoys. You have some resource that can't be accessed from multiple threads, but in a production environment, you don't know how many people are hitting that, requesting it at the same time. So you wrap things in locks, but then the first person in, however long it takes, everybody else is waiting for them to complete. So we'll show you where all those contentions are happening. And then the last one, I'm including it here for the sake of completeness, but we really don't recommend running it in production environments, is a memory allocation profiler. This is extremely impactful on the performance of your application, and it generates a lot of data very, very quickly. If you're going to use this tool, we generally recommend focusing on it in much more of your desktop environment where you're controlling the data flow coming in. And there's a great blog post that was put up about a year ago on the .NET blog on MSDNs where program manager from the task library team walked through how they use this profiler to improve the performance of the task library. But it's very much a tool we would recommend from a desktop perspective, not a production environment perspective. It's actually included in the remote tools. So when I installed the remote debugger, I have every profiler I listed above. There's one extra small feature we have. It's called tier interaction profiling. It does not include it for size reasons in the copy that's included with the remote debugger. And that happens to be a Visual Studio Premium feature as well. But this will show you all of your SQL requests that are originating from your application as well. So if you need to understand what queries are you taking, how long are those queries taking, that's something that you can do. Just like the remote debugger, it's supported in Azure. You can, when you deploy your Azure service, there's an option that you can say profile, and it'll push the tools up there, and then you have access to all the tools as well. We're going to go ahead and take a look at running this from the command line, though. So assuming that you live in an environment where you do that a lot. And so as part of my performance testing, thinking through performance, I'm using the load testing tools that are included in Visual Studio Ultimate. And I have just this basic getter function in this application. So when I request things by a presentation technology, I'm not particularly happy with the performance. It's taking about 5.3 seconds on average when I ran a load test for 12 seconds on it. So I want to see if I can go ahead and find something little in the profiler to improve that performance. So I'm going to go over to my production machine. I have an administrative command prompt here. And I'm going to go ahead and just add... There we go. So I have a little script I have just to add the path to the profiling tools onto my path variable, so I can just reference them like that. And they're installed into Visual Studio directory under Team Tools, Performance Tools. So go ahead and clear that screen. So now I'm going to say vsperf, which is the name of our profiling executable. If you're not on a Windows 8-based operating system, we had to make a couple changes. There's a separate tool called vsperf CMD. But effectively, they work the same way. They collect the same data. Just have to pick the right executable based on the operating system. So vsperf.exe/attach w3wp.exe. And let's say the file that we want to output is TechEd. So let's go ahead. So it's starting data collection. So I have my load test that I want to go now kick off, and let's go ahead and run it again. So it's going to fire up. It's going to go hit that server. And if I were to bring up Task Manager, we can see that my W3, WP process is pretty well maxed out. So as that's finishing up running, I'm going to go ahead and do a vsperf detach now. Helps if I spell it right. And so it's going to go ahead and output that file. I have waved my hands, and somehow it's magically in my operations drop already. I know, amazing how that happens. And so I have my TechEd VSPX file. So we're going to open that, and it's going to go analyze my report. And so this is going to show me what was using CPU the most frequently in the application. We noticed that as I was hitting that with the load, it was at about 88% CPU the whole time. And so it's going to use the same symbol settings as the debugger under the debug options. And it's going to, let's go ahead and go full screen with this one. And so now I have a report. The first thing we show you on the summary page is we have a hop path. So I can see what was using the majority of my CPU. And then we have the functions doing the most work. Notice I did not have the Microsoft symbol servers checked in this checkbox, so it doesn't know what functions we're executing in CLR.dll. If I check that, it'll show me that. For the purposes of this, let's go ahead and click on this app presentation controller. And because I don't have the solution open, saving your solutions is a good thing, but I can browse to find the source code. And it found it from my paths that I specified earlier. And I can see that I have this Lambda query that I am pulling in my application when I'm building my query, and I'm doing a bunch of for eaches on it. And it looks like, for some reason, doing this equals and retrieving the property is really expensive. So I have a couple options I can take right now. Option A is I could go look at that property, figure out if there's something I can do to make retrieving that property cheaper. The other option that I can do, which I've actually chosen to do here, is I'm just going to implement an app cache. Every time that request was coming in, I was going and recalculating all this stuff. If you request it, and then I request it 1 second later, probably the data in the system has not changed. So amazingly, there's a conditional already in the code that decides if we want to use the app cache, and then it's going to pre-populate the values from the app cache. It's going to try to get them, and then if it can get them, it's going to just go ahead and return that. If not, it's going to go ahead and recalculate that. And the app cache has a little bit of logic about how long it wants to keep old data in and things like that. So if I try to get data from the cache and it's too old, it's going to say, nope, null, and we're going to go rebuild this. But for the purposes of this, let's leave full screen mode. Let's go back over to our production environment. Let's go back to our wonderful web.config file, and let's flip our key value from false to true, that we want to use the app item cache. And let's say that we want it to 15 seconds should be good enough. We don't need to worry about how long it's going to take beyond that. So let's go ahead and run our performance test again. So this will just take like 10 seconds to run, and then we can see how our average response time is improved. Anybody have any questions so far while that's running and we're watching it pull back the data? Okay, so the question is going back to the remote debugging piece of this. Oh, that's okay. And so the question was, when you're remote debugging, are you able to modify the memory of the process you're debugging? Yes, absolutely. The only thing you can't do when you're remote debugging instead is use edit and continue. So you can't actually change the code, recompile it, and have that pushed into production other than that. So, and we ran really, really fast in this case. So we actually didn't even have an average response time. It was so fast. So by doing just a little bit of work, running a load test in our pre-production environment, we were able to basically identify a problem with the CPU profiler, show me right in my code where the hop path was, and then we were able to implement an app cache. Didn't take me that long to implement the app cache, and so now I've taken the average response time down when the system's under load from 5 seconds to affect almost an unmeasurable amount of time. So Any further questions? I see a question back there. How about memory profiling? We're going to talk about memory profiling in a few minutes. So, I promise we'll get there. So IntelliTrace is something that we introduced in Visual Studio 2010. How many people here have ever looked at an IntelliTrace log file? So, okay, about half the people have raised their hand. So IntelliTrace, there's sort of two aspects to it. One, it integrates into your F5 debugging experience. The other aspect that we're going to talk about today is it's able to collect data from apps running in production. And its two main purposes are reliability and performance. So the first thing I showed was remote debugging. There's going to be a lot of cases where I'm not able to attach a remote debugger. I don't know when things crash. I'm on a, maybe it happens once every 7 days, and obviously I can't just leave it running under a debugger. I only have one machine, but I want that data to be collected. So reliability, it captures exception information. It's going to capture some data we'll look at here in a minute. But it basically captures all the function calls, and it captures the parameters that were passed into that function. So if you have a bug, I've had these bugs in my code where you weren't expecting the user to enter some data, and that gets passed down the stack. You can see the values of that data as it's getting passed through your application. And then performance, this is in conjunction with the Microsoft monitoring agent that's part of System Center and also part of the Application Insights. It's a free downloadable installer, and then you can choose where it's going to push the data. You can have it output to a local file, bring that back. You can have it go up into the Application Insights cloud, or you can have it get pushed back to System Center. And there's a config file that we'll look at here in a minute, but you can choose thresholds for your requests. So you can say, if my request completes in under this amount of time, that's good. If it's above that, record that information, save a performance event, and then you can go back and look at that in Visual Studio as well. So I mentioned here, for those of you that have used Visual or IntelliTrace previously, we are no longer shipping the standalone cab. We've moved the collection functionality into the Microsoft monitoring agent. So there's a single collector for kind of everything now, production diagnostics. And I mentioned that it's integrated into Application Insights. Has anybody here seen a demo of Application Insights yet? Okay, a couple people. So we'll take a look at that in a little bit. Application Insights is a pretty cool new web portal where you can go get access to a lot of this data, and then we've had the ability to pull the data down and drill into it more deeply in Visual Studio where you have your source code. And just like everything else we've talked about so far, this is supported in Windows Azure as well. So you can just choose to run IntelliTrace, collect data from your application running in Windows Azure. And in fact, before remote debugging shipped for Windows Azure a couple months ago, IntelliTrace was the way to debug stuff running in Windows Azure. So let's go take a brief look at the IntelliTrace functionality. So sort of my story here is I have my application, it's up. We moved it out of our staging environment. We're no longer in a place where I can attach the remote debugger, but I had started Application Insights as part of the Microsoft monitoring agent. So I'm going to open an administrative PowerShell. We can just see that it's running on this machine. As I mentioned, you're able to run this in Azure, or you can run this on your own on-premise machines. You can choose where the data goes, go to System Center, can go to the Application Insights cloud, or it can actually just go to a local file. You can pull that file back and view it in Visual Studio. So we're going to say get web application monitoring status, and it should tell me that we're monitoring our web application. The display name is TechEd 2014, and it's going to the cloud. So I've gotten a couple complaints that there's issues occurring. People are seeing some slow responses. They're seeing occasional error pages like we just saw when I pushed the application into production. And so I'm going to go to the Application Insights portal page for the purposes of this. And you notice down here in the bottom left, sorry if you're kind of in the back, I guess I can minimize it and pull it up a little bit so you can get it a little bit higher on the screen. But you're going to see I have this thing that's going to tell me there are 36 exception events. There's 17 performance events, and there's one memory event since I put my application up into production. So what's controlling that is in my application, I have a file. Fine. Sorry, source control. Called an application insights.config file. And so there's a lot of things that I can do in here to configure things. So the one that we're looking at right now is for performance threshold. It's configured for 5,000 milliseconds. So anything that takes over 5 seconds is going to show up as a performance event in the portal. There's another property that says exceptions equals true in the app insight. So you take this config file, just like your web config file. It goes into the root directory with your application on the production machine, just like you were debugging it on, or just like the web.config. And you can see it's right here. And that's going to tell the collector what type of data you're interested in getting back from your application. So first thing we're going to look at is we're going to look at our exception events. So I'm going to get a list of these here in the portal, and I'll zoom in. Sorry, Internet Explorer zoomed back out on me when I change my screen resolution. And so I have a bunch of ones that I can see what machine that they came from. So all these are coming from my production machine, TechEd, DBG. But if I was running in a multi-machine environment, I'd be getting events from all of those machines. I can see which one, if there's a pattern. So if I'm seeing them occur on a single machine, maybe there's something like a network switch or something that's bad on that machine. I'm going to double-click this. It's going to bring up the event details page. I can look at some information, such as the machine, the error message, the exception data. I can look at the stack that occurred. And so all of this is simply in the browser by virtue of trying application insights. The portal that I'm showing you right here is using my own private account. There's no Microsoft magic. It's free to download the collector. It's free to set this up. It's free to try this in the portal and see how it works out for you. And then I have this button here that says download IntelliTrace. So this is going to pull back an IntelliTrace file for me that lets me drill in and see what the data was in the context of my source code. So we pre-downloaded that file. And now I'm able to come in. I have a summary page. I can see what the exceptions are. It'll show me the call stack where the exceptions occurred. And then I have this button that says debug newest exception in the group. And that's going to bring me into the context of the debugger. On the left, you can see it has my source code. It took me right to the line of source that the exception's occurring on. Down in the locals window, which let me float that up here so you can see it a little bit better, but it's going to have the exception information. It's going to say, a network-related request, blah, blah, specific instance of SQL Server couldn't be found, so I can see where that's occurring in the application. And then there's this other feature that's new to Visual Studio 2013 Update 2, that just popped up over here called Code Map, and it's giving me a visual representation of sort of what the calling path was for that request that came in to Azure. So the call stack sort of shows you, the, I'll say, non-graphical view, the text-based view where you are, and this is a graphical view and a graph form of everything that happened. There's actually a talk on Code Map tomorrow. I have it linked to at the end of the deck if anybody's interested in learning more about that. So I'm going to do a little work here. I'm going to do some research. So I know that it's complaining that it can't find my SQL instance. And it turns out that, if you notice, I'm not actually checking for handling the fact that the database might not be there. My team's moved to SQL Azure. And the funny thing about the cloud is sometimes the first time you ask for something, it might be in the process of getting moved to a different VM or spinning up or something like that. And so it may not always be there. And so I need to add some logic into my code to check for that. But I'm able to see with IntelliTrace exactly where it failed, reverse engineer that. And so now I can just put a try catch. Let's try again when this exceptional case happens. So the other thing that came up, as I mentioned, some of my customers are complaining that some things are really slow when they're profiling their app, or when they're running their application. And if you remember, back to our portal, back on the metrics page, it told me that there were some performance events as well. So every request that's coming in is being looked at how long it takes. If it exceeds the threshold that I specified, 5 seconds, it's going to pop an event to the portal. So in this case, let's pick this one, open this one. This get all simple. Took 8.55 seconds. That seems like a long time for people to have to wait. In the portal, I can see the stack for how long it took. So if I expand, it's going to show me in my code, the calling path. It took a while. I can see that I have this get all simple, and then I can see that I ran 2 SQL queries. But it doesn't look like the SQL queries are really the problem here, because I can see that they only took about 300 milliseconds. That's not anywhere near the 8.5 seconds. Again, all this is in the free trial for the portal. Did I see a question, or is it just a cough? So just like we did before, there's a download IntelliTrace file. So we're going to go ahead and download our IntelliTrace file into our operations folder. We're going to open that in Visual Studio. I have one event in this particular file. I'm going to view the details. It's going to be the same information that I just saw, but here's the magic of IntelliTrace comes in. Now when I click debug this call, it's going to take me to it in the context of my source code, and so I can look to figure out if there's anything that's going on. I'm going to walk up to frame 1. It needs to find the source file because we don't have the solution open. It's going to be in the models folder. And as I dig into this, I can see that I have some locks in this particular file. So remember I mentioned the resource contention profiler easier. I now have a hypothesis by virtue of the fact that IntelliTrace gets me into my source code to say, is the issue in this particular list that I'm retrieving things inside of a lock? And that's something that just looking at the call stack in the Application Insights portal wouldn't necessarily tell me. So the beauty of Visual Studio is that we always try to get you back to our source code. That's sort of our mantra, source, 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 back to the source code. Any questions so far on the IntelliTrace stuff that we just looked at? So the question was, is Application Insights available for on-premise applications? Yes, it is. Actually, in this particular case, these events are coming from this machine right here that it's not running in Azure. It's actually a virtual machine running on this laptop. Another question over here?
Yeah, so does IntelliTrace require an application insights, or can you monitor, have it create a file, and then use that directly in Visual Studio?
The question was, does IntelliTrace require application insights, or can it just create a file and you bring that file directly back to Visual Studio? Absolutely. So I mentioned there was 3 different ways that you could choose to have the data output. You could output it to Application Insights in the cloud. You could output it to System Center, or you can just choose a local file. It'll leave a file on the machine. The big difference is in the particular cases that I showed, you notice that there was only one event in the various IntelliTrace files. If you were to, for example, dump it to a file, in Application Insights, every time you have an event, it creates an IntelliTrace file associated with that. If you're running it locally, it's going to create one IntelliTrace file. So you might have, I had 37 events, I think. You'd have 37 events in this file that you'd go through on the summary page as opposed to just one. Yes, question? So the question is, can it be applications like console apps and things? Theoretically, you can have it monitor any app that's running managed code. There's going to be perhaps a little bit more manual setup that you have to do. It's not just like it's tightly sort of magically just works when you install it. It just automatically hooks into IIS and starts monitoring everything in your app pool. If you want to get it to monitor an desktop application like a console application, you have to do it's not going to be quite that magical because you're going to have to tell it what you want it to monitor, but it's possible. Any other questions? Great. So per the question that was asked earlier, the next thing that we're going to talk about is .NET memory analysis. So memory is sort of one of these interesting things. Oh, whoops. You're not seeing that. I apologize. These interesting things that a lot of people I've talked to, I said, oh, do you have memory problems? They said, well, we used to when we were an x86 process, but we don't have memory problems anymore now that we've moved to x64 processes. It just means you're hiding the issue. You're not getting that a memory exception. Memory sort of falls in the category of being a good citizen on the system a lot of times when you have an x64 process. As people are moving more and more towards the cloud, a lot of times you're actually getting less memory on the machine than you had before because you're now paying somebody else to use their RAM. So even though you're on a physical machine with a lot of memory, you may be paying for a virtual machine that has 8, 12 gigabytes of memory available to all the applications running. So if you have 10, 20, 30, 50, 100 applications all running inside on that machine, if you have one process that's getting really big and being a memory hog, it means you're stealing memory from somebody else, right? There's going to be a performance consequence to that in the sense that you're going to require a lot of paging. When that other request comes in on the process, if your application is not, the machine has to pay a lot of performance consequence. So even if you're in an x64 process and you're not going to get an out-of-memory exception, it's actually a really good thing to be proactively on top of your memory. And sometimes, with load testing like we did a little bit earlier, you can find memory issues. So our .NET memory analysis tool that we added to Visual Studio 2013 it allows you to identify unintentionally retained and inefficient use of memory. So more often than not, the problems that we hear people having are leaking memory. Right? Managed is kind of this weird world where, unlike native, where you had to make sure to clean up the memory before you left it, in theory, you just get to allocate your objects, go, the garbage collector will clean up for you. But if you are accidentally keeping a reference to it from anywhere that you sometimes didn't even realize you added or didn't think about ahead of time, the garbage collector says, oh, this object's still being used, and your memory can get bigger and bigger. The other thing is sometimes you can just do really inefficient things with memory. Maybe you did a select star in your SQL statement instead of something else, and you're pulling back 180 megabytes of memory. You said for performance reasons, I'm going to hold that data in a cache, when the reality is you needed like 3 rows. So now you've just, by virtue of one person requesting one thing, you've put 180 megabytes in memory by virtue of that. So we allow you to see the size, the counts of all object types that are in the managed heap. So if you're a managed-only process, then that's probably what you mainly care about. We allow you to see the references preventing the object from being collected. As I talked about the garbage collected world, you can see why isn't this being collected. And then we give you the ability to compare multiple snapshots over time. So a lot of times from a leak, you say, okay, well, I have the snapshot, and I can see what's in memory, but I'm not really sure what's growing. So you can take one now, you can take one later, you can say, what got bigger? We have sort of 2 ways to view the memory data. One is something called Diagnostic Session File. This is supported in the Application Insights Collector. It works on .NET 3.5 and below. 3.5 here means the runtime that's installed on the machine, not what your application is targeting. So if you had an application that's targeting 2.0, but your system administrator has installed .NET 3.5 on the machine, your 2.0 application is now running on the 3.5 runtime, and this will work for collecting data. And that requirement's actually there because the collector requires 3.5 to execute. So it's hard to collect data when the collector won't run. And we now even have the ability to pull these down from Azure websites. I'll mention our blog at the end. There's a great blog entry on how to do this, but if you're running an Azure website, you can go run a PowerShell command. They have a REST API. You can download a diag session file directly from your Azure website. And Azure websites are x86 processes. You get 10 Azure websites for free. So if you want to play with Azure websites, you can go play with them for free, but you may actually find that because of that x86 restriction, you have to care about memory a lot earlier in the process. And then the other piece is heap dumps. So when you collect a dump file with the heap, that means it has the memory. That's why we need that information, because we can't tell you what's in memory if the dump doesn't record what's in memory. Other cool thing that we've done with this is it allows you to see the same things that you can see in diagnostic session files, but because we have the entire contents in the memory, you can actually drill into the values of all individual objects. So, and I'll kind of show both of these here in a minute. So let's go over and look at the memory analysis capabilities in Visual Studio. So I think I mentioned that in our App Insights portal, we also had some memory events, if you noticed. And so I can see that I had one memory event. It tells me that it exceeded my threshold. As I mentioned before, we have our Application Insights config file. One of the other properties in there is I can set 2 sort of really interesting properties. One is where I collect my final snapshot. You can key it off of the percentage of the IIS recycle settings, or you can use units like megabytes, gigabytes. So in this case, I've said I want that to be collected when the process reaches 550 megabytes. The other thing that I can set is I can say collect a baseline. Remember I mentioned the diff experience earlier. And in this case, I'm going to say when it reaches 400. So process is up and running. It crosses 400. It goes and takes a baseline snapshot. If it continues to grow, it crosses 550. It creates a second one, creates an event, pushes that up into the Application Insights portal. Or I could go get that off the local machine if I had access to the local machine. And I can see I have a memory event. It tells me why it fired. It crossed 550 megabytes. And because the App Insights config file is on a machine-by-machine basis, you do have the ability, for example, if you were doing this on different physical machines, maybe you have one machine that has 12 gigs, you say, okay, I want this to have 2 gigabytes of memory. Maybe you have another machine that's actually only 4 gigabytes of memory, and you say, okay, I only want this to have 500. So you can do that configuration. I have a graph here that shows me the last 15 minutes of memory use. This one actually spiked up really quick. And then I have this download memory snapshot file. So all I can really see here is that the event occurred and the graph on the trend line. If I want to drill into this data, I have to bring it back to Visual Studio to view it. So just like before, our operations drop. I've already downloaded this for us. We don't have to wait for the download. And so it's going to open the Diag session file. It's going to load the memory data. And you can see, because I had a baseline set and an upper threshold, I'm automatically in a diff view. I can choose to compare to nothing, but most of the time we're going to be interested in comparing to our diff. And I can see what's growing in memory. Sorry, my screen resolution is a little small here, so you may not be able to see everything. But one of the things I see that's actually growing is this concurrent dictionary. And I can see that there's only one of them, but it's actually increased in size by 132 megabytes since the last time that I was there. And if I look down here in the reference graph, which is what I'm looking at down in this bottom part, I can see the paths to root. This is what is holding it alive in memory, preventing it from being garbage collected. I can also see reference types. I can see what it's holding alive in memory. So this is sort of some internal structure, but I can see, drill through and figure out where my memory is going. All my memories are going to these nodes, and these nodes are actually holding these queried app item things. Looking at the reference graph, and expand this out all the way, I can see that it's a static variable, this m underscore app item cache. So remember I added a cache before to fix my performance problem when people were requesting stuff, and it looks like the cache is holding too much stuff alive in memory. So the question that I want to ask now is I want to say, okay, is the issue the efficiency of my cache? Is it just not aggressive enough about kicking stuff out? Or do I actually have a leak in my cache? I might be able to go look at my source code and reverse engineer that. But in this case, I'm going to go ahead and back to my operations drop. And I've gone and collected a dump with heap of the W3P process. And so I'm going to open that in Visual Studio. And I'm going to go ahead and choose this debug manage memory option because I have the heap. I can drill into that. It's going to take a couple seconds to analyze. We have a 600 megabyte dump file. And let me go view full screen just so we can look at it. And so now, because I have the full heap, I can actually drill in. So let's go find these queried app items. So I can see that there's 64 of them in memory. Click the view instances. And now, just like I'm debugging, I can hover over these and I can inspect their values. So I have data tips when they eventually evaluate. It has to go walk through the heap to find them. And so what this allows me to do is to go look at the properties on these things. And so I can see the name of this is RAW, not many tests, blah. And if I look at this one, I'll actually see that it has the same. And so as I start looking through as I start looking through the objects in memory, I'm going to see that I'm actually putting multiple copies of the same thing in my cache. So indeed, I actually have a bug in my cache logic. It's not just being inefficient, but it's leaking things. And what we're just showing in the value column is the debug display attribute. If you went to the debugging tips and tricks talk, you have the ability to add attributes in your code that tells the debugger what you want to see. So here, if I want to look at the name of the app, for example, had I added a debug display attribute that says name equals this, instead of showing me the type, I would be seeing the name equals this. So just one more reason to go do that in your code. It's just a really good practice for all debugging things. So I'm going to file a bug on myself. I can see that we're going through our time in the session, and so you don't want to watch me go figure out how to fix my cache logic. But we've identified that I really do have a bug. Any questions on the .NET memory analysis piece? Awesome. So dump debugging. Who here has ever debugged a dump? Okay, about a third of the room. So dump debugging is basically a process of the snapshot at a single instant in time. For most cases, you can think of it just like you're at a breakpoint at that moment in time, but it was collected. You can just collect it. It's a file. It's saved off. Like being stopped at a breakpoint. It's ideal for crashes, hangs, and memory issues. We just looked at it for debugging a memory issue. Crashes, we'll look at that here in a minute. And then hangs, just like you'd debug a hang if you were live debugging, you have the threads window. You can go look between the threads. You can see what code's executing. You can see what's hung in memory at the time. If you have the heap, we just saw, we can actually see the values of the objects in memory. that is true. You don't have to just be using the memory tool, right? You have all your variable values as well for anything that's on the stack. If you don't have the heap, it's a much, much smaller dump, but you're only going to get call stacks. So sometimes, you save a dump off. There's different options. Someone says, oh, that's too big. It's a 1.2 gigabyte process. I'm just going to save it without the heap. And you can see what code was executing, but you're not going to be able to inspect the values. So if you can reverse engineer it from source code, sometimes no heap is good enough. Just looking at the source code, say, OK, this is the line that it crashed on. Oh, I can see that it was a null reference exception. Maybe, I see that I forgot to check if this was null. But sometimes it's more, you get some error message, right? You have no idea what it is. Oh, I really need to see what the value of that string was that I wasn't expecting. The nice thing about dump support is the collection is built into the operating system. All the tools that do it, you can do it from Task Manager by right-clicking on a process. You can use procdump. You can use WinDBG. You can use Visual Studio to save it. They all call the same stuff in the operating system that says, please create this dump file for me. So they're usually pretty easy to collect. So we're going to go ahead and briefly look at debugging dump. Unfortunately, in this case, I wrote this application, unlike the previous web application I've been looking at, so I can't blame anybody else for my own fault here. But I have this, let's go ahead and into our archive, and I've saved off a copy of this WPF client that's going to try to show me the same thing that I was just doing. So I'm going to launch my WPF client. It's supposed to be a client version of the website that we were just looking at, and it's going to blow up and it's going to crash. So what I'm going to do in this particular case is I'm going to go ahead and launch a command prompt, and I'm going to use procdump to collect this, just because it's a really good tool that we usually point people to. And what is the name of our procdump? That makes sense. So this is just going to add procdump to my path, just like I added the Visual Studio profiler to my path. And so we're going to go ahead. And so we're going to go ahead and launch procdump, and we're going to tell it to use a /e flag, which is going to tell it to capture dump whenever an unhandled exception occurs. I'm going to use the /ma flag, which is going to tell it to capture the full heap so I can see the values of what's going on. And I'm going to use the -x flag to tell it to launch the application. I can attach, but because this is crashing in the startup path, I'm going to say the name of it. We'll call it client.dmp, and we want to launch WPF client. So it's going to go ahead and launch. It's going to blow up. And you can see that procdump is writing out a crash of the file for me. So we have our dump file here, the WPF client. Procdump appends a date stamp to it. Same dump summary page we just looked at before, but this time we're going to go ahead with the debug managed only, because I had a managed process. I can choose the debugger that I want to debug, managed, mixed mode, or native. If I'm a managed only code, I just want the managed only debugger. I don't really care about the native code that's on the stack. And just like I was live debugging, it's going to break. It's going to tell me that an unhandled exception occurred of system.web.net exception. It's going to tell me where it occurred. This was an optimized dump. So if I look at the modules window, you can see that I haven't loaded symbols yet. So I'm going to go ahead and load symbols for this. I'm going to go find my symbols in my archive. So this is another trick. Because this is optimized, there's actually 2 WPF clients DLLs in here. There we go, and symbols are loaded for this one. So I'm going to walk back up the stack. And one thing you're going to notice is none of my source code is on the stack at the moment. That's because of the way the underlying framework works. So how do I figure out where the exception's occurring in my application? And the answer is actually in the watch window. We have this exception pseudo variable. And so I can drill down through it, and it's going to, I might have an inner exception. Sometimes in SQL, you can drill through the inner exception here. In this particular case, it's going to tell me that no connection could be made because the machine actively refused the connection that I was trying to make. So it looks like it's an exception that's related to somehow when I'm trying to call the client out. And then I have this variable that's called stack trace. So I'm going to use the string visualizer to bring this up. And so this is a string that's a property on the exception that's going to actually tell me where in code the exception originally occurred. And here I can see that I have WPF client main window.xaml.cs line 37. So if I have symbols loaded, it's going to actually be able to tell me the line of source code that occurred on. If I don't have symbols loaded, it's not going to be able to tell me that. Here I can see that it was line 72. So I can see the pieces of my code and the line in source code that are on the stack. So let's go ahead and open my solution for this project. And this time I'm going to go ahead and open it out of my archive. I'm going to go to the file, main window.xaml.cs. Let's do a Control-G to line 72, and let's see what's going on. And sure enough, I can see that I'm creating an HTTP web response, but I haven't guarded for the fact that I might not be able to connect to the service. So instead of giving the user some message like you may not have connection to the server, I'm actually just blowing up and crashing the app. So I'm able to use dump debugging to nail that down and identify that as well. Any questions so far? Awesome. Well, thank you. So I promised that I'd have some resources and some other stuff. We have a blog on the Diagnostics team blog. The link's here. You can go download it from the slide deck. We blog about everything new that we do. We also do some tips and tricks. So we'll do series on using breakpoints or things like that. There's a couple other sessions you may be interested in. The top one, Dev B352, was given on Monday, so you'll need to go watch the video for that. But there's, I think, over 60 tips on using the debugger more effectively in there. I talked about some of the things. We did actually coordinate to try to not overlap. So the stuff that I talked about here, it's not going to be a repeat of that. The stuff that he talked about there largely should not be a repeat of what you saw here. We're doing another talk. So my manager, Daniel Moth, gave the talk on debugging tips and tricks. We're doing a talk tomorrow morning on diagnosing issues in Windows Phone 8.1 applications. If you're building the XAML applications, if you've seen any of the talks on the new universal app types, we're going to talk about the tools we've built to help you diagnose those. And you briefly, very briefly, saw CodeMap and IntelliTrace. There's actually a session on that tomorrow, getting the most out of your code maps. So if you're interested in code maps, you should go check that out. I have downloads to the remote tools and the Microsoft Monitoring Agent. So both of these should take you to the most recent version of both of those as well. So visit the developer booth. I have one more brief plug for a friend of mine, Carl Melder. Carl, you'll stand up and wave your hand. He is a UX researcher. And if you've ever used code analysis, so FXCOP for C# programming, they're doing some usability studies. They'd love for you to come talk to them and give them some feedback on some ideas that they're thinking about for the next version of Visual Studio. And he'll be up front afterwards if you want to come sign up with him. And then please complete an evaluation. Just a lowly member of the product team. So if you found this useful and you think there should be talks like this in the future, make sure that you go give us a good evaluation so they can justify sending us back. So thank you very much.